Dharanya, please start the session.
Yeah, yeah, yes. A very warm welcome to everyone gathered here today. I'm Dharanya, PhD scholar in Remote Sensing Division, Civil Engineering, IIT Bombay. So thank you for taking your time to join us for today's session of Grow and Monthly Talk Series. So for those who have joined us new today, so Grow and was founded with the vision of bringing innovators from interdisciplinary domains together to prosper collectively. So insights from experts like Professor KP Sudhir, Professor Edo, and Professor Jyoti Prakash help us evolve into Grow an initiative dedicated to networking and collaboration beyond institutional boundaries. So as we know, networking is the cornerstone of growth. Grow and was founded to foster collaboration and facilitate knowledge exchange and open up avenues for innovation. So the main aim is to bridge the gap between researchers working in the same domain, but often in silos. So now today, Grow and is not limited to any one organization. It is open to anyone willing to contribute and be a part of this community. So among the many activities in the pipeline, we are delighted to launch our initiative, the monthly talk series titled A Lifetime of Experience. These sessions will feature eminent personalities from diverse disciplines who will share their invaluable sights and experiences. So we are honored to have with us today Dr. N. Sankhua, member of Krishna River Management Board, Ministry of Jal Shakti, to deliver today's talk. Thank you once again for being here. I now invite Professor Vinay from IIT Jammu to formally begin the session.
Thank you, Dharanya, for a brief introduction. On behalf of Grow N, I welcome you all to the second expert talk in Grow N monthly talk series. It gives me immense pleasure to introduce our speaker today, Dr. R. M. Sankhua, a distinguished field expert in water resources management. We are truly honored to have Dr. Sankhua with us today, as he graciously agreed to deliver the talk for this Grow N monthly talk series. Grow, Dr. Sankhua is currently serving as a member of Krishna River Basin Management Board under Ministry of Jal Shakti, Government of India. He holds a PhD in Water Resources Engineering from IIT Roorkee. He specializes in hydroinformatics, basin planning, and watershed management. He has led the planning and design of 16 river interlinking projects in peninsular India. A prolific academic, he has authored 6 engineering books, 3 novels, published 195 technical papers, and guided 6 PhD and 30 master students. As a former director of National Water Academy, Pune, he organized 60 training programs and delivered over 1,800 expert lectures. His work emphasizes the integration of advanced technologies with sustainable water resources planning. I strongly believe his insights and immense value to add immense value to our understanding of sustainable water resources planning and management. Please join me in warmly welcoming Dr. Sankhua. Sir, uh, Dr.
I'm audible
Sankhua.
to you? Yeah,
Yes,
audible.
yes, you are audible to me, but your video is off. Could you please
Video
switch it
is
off?
on. Yeah, I have tried that, but video is on now, but it's not taking. I don't know. Video is on.
Okay,
Video
sir.
is, yeah, I
Yes,
have.
yes.
Blank is looking blank only, white blank. Light is on only, but video is there on, but it's not showing the photos. Anyway, because of maybe this network issue, huh?
Sure, sir. Sure, sure,
Strength
sure.
of
Sir,
strength
please, the
of
session is yours. Yeah.
Okay. So, shall we start it now?
Yes, yes, sir. Yes, sir. Please, please. Thank you.
Okay. Okay. Thank you. Thank you. Okay. Good afternoon, one and all. First of all, I wish to express my thanks to the organizers and especially to Professor Basudha Biswar, Dr. Bina Kumar, Mr. Kunal, and appreciation to all the participants and through you, the entire members of the Grow and Group for this opportunity given to me. I deem it a pleasant task to be called upon to deliver a talk in this platform on the topic that is field engineering from blueprints to bureaucracy. So that is what my experience says from my 35 years of experience in the field of engineering. Now, just before that, I would like to show one small clip to you. If it's visible to see.
Yes, sir. Visible.
Yes. Anytime it's just obstructed, kindly tell me, okay?
Sure, sure, sure.
This clip shows that engineers are the best amongst all, and generally engineers stay in heaven, not in hell. So once one engineer dies and goes to hell, and what happens? See from this clip. And further, this cliff did not move. Anyway, so this devil asked, that God asked devil, so how did you get engineer in your place? So devil said, but by chance we got it, and now these roads are repaired, the AC is working, the swimming pool is working, and everything. The engineer said it right. And God asked that this is not the place for an engineer. So how did you go there in wrong place? And devil said that I won't leave the engineer from here. So he's doing good work over here. So everything he has turned into good. So what I meant to say is that wherever an engineer goes, he makes his best and makes the place beautifully arranged so that others can live happily. That is what my message is from this clip. Anyway, in this talk, I'll be talking about the lessons from my life, practical lessons from my life, what I had throughout this 35 years of experience, particularly 32 plus years experience from Central Water Commission and Ministry of Jal Shakti. And in this journey, I had started from particularly CWS Central Water Engineer Services through EPSC that started from 1990 batch. And I joined as Assistant Director at Patna, that's Lower Ganga Basin Organization Patna. Then after that, I was promoted to Deputy Commissioner. Then I was in Remote Sensing Director, then Central Water Commission. Then I was in National Water Academy Pune as Deputy Director. Then I became Director over there. Then I was transferred to Basin Planning Management Organization in New Delhi. After 4 years of stint up there, I had been to NWA National Water Development Agency as Chief Engineer, Hyderabad. And after 5 years over there, then I came back and promotion to this KRMB as member. This is an higher administrative grade officer here. I am working since last 1 year and 4 months. Now, talking back to this subject concern of this experience, you know that practically in the field, we have to unravel the unexpected, where the concrete makes the confusion and every drawing needs prayer before execution. You execute a dam, a barrage, a tunnel, anything. So you need to have a prayer before, because what will happen in future that you do not know. So in the world of real engineering, field engineering particularly, the line between disaster and success is often just a matter of perspective. Sometimes the tunnel that leaked like gossips, you recently might have heard this this is Srisalem Left Bank Canal Tunnel, how it collapsed. And I'll give example to that what happens in the field. As engineers, you see, we are often thrust into situations where only certainty is uncertainty. Imagine you are standing in the middle of a tunnel project and thinking that this is going to be perfectly done, only to have the earth below you stubbornly refuse to cooperate. That you do not know what will happen in future, whether that will cooperate or not. And the concrete to which you are pouring down, that behaves like an unreal child. Every time we add measurement, that is greeted with the same loving response confusion. We are confused and our staffs are confused. The measurement which you are taken, that is wrong or right or in between, that you do not know. On the other side, going for water sources, so I am seeing this telemetry since last 20 years time for this monitoring of this irrigation projects, for water sharing, for water optimization and water regulation states. So here you are using telemetry, often telemetry which is considered to be direct one, but not always harmonious. Sometimes the relations between the high-tech monitoring system and the unpredictable realities of engineering that gives you. So this telemetry, what happens? They're supposed to give you the real-time data. They sometimes seem to suffer from this identity crisis. That means suddenly your perfectly calibrated SLDCB, that means a side-looking Doppler current profiler, goes out of order and starts screaming like in panic. That means it's give us alarm sometimes. And we fail that time during floods, particularly if it's SLDCB gives alarm, that means we cannot measure this how much flow is there. We are in trouble that time. So before you bring the huge drawings to life, say for example a barrage or dam, like Kenbetua Dam is being constructed, Dudhan Dam that is constructed. I'll show the clip to you also how it is being constructed, what the problems are we are facing. So before you start a big project, we often whisper a small prayer. As I said, so we have to ask God for a divine intervention so that or intervention so that at least we can go smooth on the way. There are many people will be dying, many people will be lost, and some because of these surveys are wrong, sometimes we go mistaken and the contractor's tool are misplaced and weather is against us. Because of all these things, we guess we get some problems in the field then. And what happens? The tunnels which are constructed that is leaked and canals that lined, they get themselves lined. That means bad lining is there. Dam that caused the political floods. That means something else is that which dam wanted to solve that could not solve. And the site visits were team matter more than telemetry, because you know that in engineering field, particularly civil engineering, more things happen in the field than in office. So what are the things? Openly, I'm not going to discuss that, but still, the T matters more than telemetry. T means maybe more than T. Okay. So we are not just designing the dams and tunnels, we are also taming the nature, bending it to our own way. Not that. So though sometimes nature has a better sense of humor than we do. In the real world of engineering, water flows exactly where you want it, but at the right time with the right pressure. But sometimes in the reality in the world, in the field, what happens? We have to deal with an endless range of challenges, from geological to political surprises, and that requires us to constantly adapt and improvise. So hydro diplomacy becomes a bit more of a political economy rather than water engineering something we feel in the field. So anyways, what is that? We'll be talking about that in details here. And when he says this tunnels are just not typical leaks, so these stories are there. We can forget these things for some time, and after that we can get it back. What happens to that? And let us not even get started on the drama of canal lining. Say this. That is the beauty of field engineering, where people want it and where nothing is ever truly predictable. And sometimes a good cup of tea is the best solution for a stressful situation, if you think so. And some people, and those who do not take these sort of things from outside, generally they are happier ones, and they face problems sometimes, or most of the times they face problems. And field engineers work through the mismatch solvent deadlines to that streams to stretch. And we navigate a maze of moving targets. Anytime we just start with the project that goes on delaying, and each one representing a different stakeholder. Contractors, so we think that schedule is a suggestive one. Consultants, we are just waiting for the clarification. And of course, politicians who want the project done yesterday. Every 15 days, they will tell that it is not completed. Why it is not completed? What is the reason behind that? How come one dam project or barrage project or tunnel project can complete it just 15 days back or within 2 months time or 1 year time? It's not simply possible, but they want that this to be completed yesterday. And then comes there is paperwork. So this is the most tragic part when sitting in the office, the endlessly shifting of files, of approvals, of government regulations that seem to have lives of their own. Because the clock sitting on that clock means I talk about babuls. We submit DPRs, we submit estimates, attend meetings, and somehow manage to keep our sanity mostly intact while making sure that the project progresses smoothly. Because you cannot make a noise, you and cry over there because the files are with the minister, your files with the senior minister, or maybe with the chief secretary, secretary of the center, or somewhere else higher up, maybe in the finance ministry, somewhere else. Anyway, so about me, I need not talk before I dive deeper into the specifics. Let me introduce. I'll be going to tell you about this career things which we faced during my lifetime of 32 years in Central Commission, 32 plus years Central Commission, and elsewhere, remaining 3 years. So first thing is survey and investigation. When you go for survey and investigation, you have to access the remote terrains. So while accessing the remote terrain, what happens? Suppose, for example, make a DPRs of DVG, Damanganga, Vaitala Godavari, Damanganga, Egdar Godavari, Godavari, Kaveri links, Almaty Penar, Berchi Vardar link, Srisalam Penar link, Kaveri Vaigagundar link, Ken Betwa link. And you have to go to the hilltop and better it, particularly the Parthavi Narmada link, Damanganga Pinjar link, which was for Mumbai Sea Water Supply City. That links the region known for the public unrest. Everywhere we get the public unrest. And carrying surveys and investigation through these unrest areas is very difficult. The result is simple. Survey and investigation side is often more challenging than the actual surveying itself. As you said, I just said that. And there will be mudslides, there will be security roadblocks. And as you know, that the truth is, even the best engineer cannot measure the heights that they cannot reach. That is what happens in the access to terrain areas. And then next phase comes that when a new inexperienced staff comes, engineers come, they do not have the experience. And also we have more experienced but corrupted staff. So when both you face problems, and in a new inexperienced field staff, you will have a recipe of data errors or know-how less. That would make a water resource planner weak. Particularly ILR drone surveys, when are taking drone surveys in some Chambali that Chhattisgarh and that Godavari area, we had a lot of problems because people, those are coming BTech and MTech, they do not know what is the derivables from the drone survey. They do not know what happens after drone survey. They do not know what to do with the drone survey data and all that. So directly with the laptop, they are getting the data, but what to do with the data, how to compile the data, they do not know. Even after training 15 days, 20 days, 25 days or a month, they do not know what is that. Then drilling this dam accesses and drifting this dam access survey and all that in survey and all that. So they do not know what is dam access survey, what is drilling and drifting. They do, because it's BTech and MTech, that is not taught. That is not their mistake, because they are not exposed to the field conditions and the fatal exposures. Though they have studied master degree and BTech and MTech from good colleges and reputed colleges, but they do not have that knowledge of drifting and drilling and why it is done, how it is done, and how it can be better done. Next, sometimes weather dependency. When monsoon that comes, that is in queue, most unfortunately, we have the problems. It has a lack of disrupting every field investigation. Whatever borewells we make, that turn into lakes, because borewells are lakhs of rupees cost, one borewell is in. River cross-section surveys becomes water rafting expeditions, and the overall productivity of this survey and inspection team plummets. So that happens in the weather depends sort of thing. And sometimes we face the problems of data discrepancy. If we try to reconcile survey data, which phrase substitution, that becomes a problem for us. The mismatch of old data with the latest findings is like trying to patch a leaky boat with a bubble gum. Okay, so I am giving examples why what happens to us when I just go to that. And add to that the lack of uniform data systems, and you have to disaster waiting to happen. So that is happens to the senior most engineer who is in charge of that. This drone server, we generally send instructions to the diggers or automatic builders, machines particularly, and we get the 3D visuals from data from one side machines and ensuring ability proceedings as per specification out. That is what you get. But if this is interpreted input, so taking the next step of data, that will be some costly, that will be some lakhs of cost that will be spending in that. So generally what happens in the work progress arena, if you see the expectations what you expect that it will be going in straight line, it doesn't go in straight line. In practically, the reality happens that this every year or every time that changes like one chord path. So the progress what you want to see in the proper time, that doesn't match a straight line as you expect. That what happens in the real field works. Okay, so I'll give you one example to that. Say, this is one Pinapuram, that is IREP Punapuram. IREP means Integrated Renewable Energy Project Punapuram. Here we have this PSP, pumped storage plants and solar plants, wind plants. This is near Kannur. If someone of you have visited this area, this is a nice and excellent project. This is the first time in the world, so that we are having this sort of projects where you don't need a river to generate power. Here are generating around 6,680 megawatt of co-located projects. This is the world's largest integrated re-storage project. And low reservoir, the reservoir, upper reservoir will collect the water, that will be automatically gravity that will come into low reservoir, and low reservoir will pump it out to upper reservoir again through by pipes. So there, once time in life, you have to fill this reservoir once. Upper reservoir you have to fill once only, and throughout its lifetime, 30 years, 40 years, 50 years, 60 years, it will automatically run and generate the power. Right, so we are seeing the powerhouse, and we have other structures also. This side is solar. Wind fans and all that, they'll be generating power. And now, if you see, these are turbines. These are some 6 turbines, 4+2 standby. These 6 turbines are generating power for this mega project. This is around 30,000 crore rupees cost. These are the solar panels over there. This is Pinapuram, nearby this Kurnool. And once you see this project, so you'll be at least happy that these projects still exist in India, where nowhere existed in USA or China or anywhere in developed countries of the world. So first time in Andhra Pradesh, in Kurnool, they could be able to do that. And under Central Electricity Authority, this has been done, right? So see this, these are the real states of this 6 into 240 megawatt and 2 into 120 megawatt power generation sort of thing, this hydropower sort of thing. And when we visit that, this is the reservoir of the left side top, we are seeing this is the reservoir. And right side, this is the power sort of thing. Those are the chief engineer, engineer chief, and all those staffs over there. So we had been there. And these are this reservoir, 4-bay, and what will coming and this thing. So construction is almost at the end stage. And so 1 or 2.
Yes.
Yes, sir.
Yes, sir. It's okay.
Okay, that's good. Now, what happened?
It's okay, sir. It's internet speed is slow. That's what it is stopping.
This constant road is going on over there. This is drilling for this dam access and all. And this is the gutter construction is going on over there. Then the auxiliary construction canal link is going on there. That means it's in full swing to make the dam and roads and all that. This is another Kaveri Godavari Kaveri link. Is visible?
Yes, sir.
Yes.
So what happened here? So what I showed that we planned in virtual GIS and that we are going to execute once this Telangana government is ready, because AP government is almost ready, Telangana is almost 90% ready, and Tamil Nadu government is already ready. Kerala, Karnataka, other governments are ready. Only thing is that because the Godavari is co-signed by 7 states, so we have to make agree the 7 states for this. So once they agree, we can execute that. So what you plan in the office, that in the field engineering, you can execute in this thing. So starting from construction, starting from the hydropower project, starting from your installation of these turbines and your all the flows and power generation, everything you can do what you plan. So what happens, the construction challenges what you face actually, there are many. Like Polavaram I was talking about. So like Ken with what you are facing. So there are problems of material and foundation. In foundation problems, if there one thing is that keeps engineers awake at night, and it's weak strata or unnecessary slippage zones. So sometimes you go for redesigns, you go for the groutings. What type of grouting will take up? Either you will go for pure grouting or for direct grouting or shortcutting or what are this, or you go for this other type of grouting. So that I do not know. Next morning you can decide what type of, suddenly you have to decide what type of grouting you can instruct this contractor. And also material quality control. So material quality control, that's the problem because we're getting this bentonite slurry for this core of the dam. This is very difficult to get it from the dam site. So we have to locate somewhere else, which may be 50 kilometers away, which may be 100 kilometers away. So the theory says that the lab test should be indicate the perfect quality control, but actually that doesn't happen here. But in the field, what happens? You realize that what you see is not always what you get. That is what is happening here. Variably in aggregates, concrete or compaction can turn the most well-planned construction site into a chemistry experiment gone wrong. So that what can happen? Even the crores of rupees that will be wasted over there. Then sometimes you get hydrological surprises. So you can set your clocks by the monsoon rains. IMD gives this predictions, but the unexpected floods that comes like this Polavaram dam was, the copper dam was flooded out, was away. So those are like that surprise exams you do not study for. Unseasonal rains disturb the copper dam installations like Polavaram said, and that makes you wish for a slightly more predictable hydrological prediction. But you cannot always think the best of it. Sometimes we have the instrumentation and monitoring problems. So have you ever gone to check the dam instruments like piezometers or strain gauge, something that? So they sometimes are malfunctioning. You might have seen Nagarjuna Sagar or Srisalam. Srisalam is 8 mm just tilted. So because of that is malfunction, sometimes you can change, check. And this is also sometimes buried under the tons of sediment. So this is sometimes not calibrated properly. So it is like trying to measure the depth of a pool without a broken with a broken thermometer sort of thing. So that happens in instrumentation monitoring while constructing the projects. Sometimes clearance delay. This is the most important part of this project is a clearance delays from bureaucrats. Because above you, so Babu said. So that happens everywhere in all the construction projects that this bureaucrat delays will be there. So environmental clearances, forest permits, and RR issues, resettlement issues can stall your dam project or other projects faster than you can say. So next is the construction of tunnel challenges. That means in the tunnels, really, you could see that so 2 months back we had this SLVC failure, Srisal left bank failure, 8 people were buried, and the tunnel was around 43 kilometers long, the longest tunnel in the world. And here the tunnel is not having any audit or any shaft. The problem is that because this is a water tunnel, the diameter of tunnel is 10.2 outside, 9.2 inside meters. I'm talking about meters, 9.2 meter inside. So what happens here? You see this unforeseen geological conditions, rock masses, heterogeneity, fault zones, sometimes water ingress that can turn your perfect tunnels into an underground nightmare. That happened in SLVC. Suddenly, your beautiful plant tunnel morphs into an impromptu swimming pool. So like this 12 feet, the flocks is there where we could not rescue all these laborers or this because this TPA machine is 120 feet long and TPA machine is completely destroyed and the persons, the driver, including the driver, other laborers, foremen, all are went missing. Missing means the flocks that are missing. That till now also that has been suspended. No one could be, only one person was recovered, other person could not recover because of these flocks. And suppose you have real-time data lacking. Suppose you are imagining to dig a tunnel blindfolded. That is what it's like when you lack a reliable geotechnical telemetry. Without real-time data, safety and progress become impossible balancing act. So sometimes we have the ventilation problems and safety hazards. So ventilating a long tunnel is like trying to open a window in the summer rain. So this same sort of thing happens with us. Dust, gases, and your compressor and heat becomes a silent and but dangerous companion. Sometimes carbon monoxide, sometimes carbon dioxide. So NO gases, NO2 gases. So these gases come suddenly and you do not know when it will come. Nighttime, daytime, you do not know what comes because that is not visible. So that gives a problem to us also. Even the compressor works properly also, then also that is not sufficient to flush out those things. And alignment deviations. What happens in railways when we are having construction that care project in railways? So this OCC, Odisha Construction Company contractor, they made 18 meters gap between this. Both hands they were attacking, and the mid person they could not beat it. 18-meter gap was there. Because of that, I fined them 18 lakh rupees. But anyway, so fining is not the solution. So the slightest survey mistake today can lead to a mismanagement or misalignment tomorrow. It's like setting the foundation to a skyscraper and realizing that you build 2 degrees of center. So that is what the cost to correct it is enormous. Sometimes in thousands or lakhs, sometimes in crores. So this what will happen? So you have to rectify that because if something goes wrong, so you have to rectify before and if you could not rectify before, then that will be like this. Then sometimes slow excavation line. Slow excavation means this SL-based tunnel is since working since last 15 years. JP is the contractor. Here this he has been paid for last 10 years. The cost is around 5,000 crores. But because of non-payment, he did not do the work. So this, as I said, the 43-kilometer tunnel, 10.2-meter outer dia and 9.2-meter inside dia and lasting the last for 14, 15 years, that is still working. Disposal of muck, that's a very difficult thing. Though you plan for muck disposal, but sometimes you have to go for proper planning. If poor planning is there, then tough terrain that makes the muck disposal very difficult one. And that is one of the difficult jobs in civil engineering, particularly in terms of construction. And other issues like you have this canal lining issues, subgrade instability is there. Sometimes contractor shortcuts there. Contract shortcut means contractors sometimes seem to believe that quality control is optional, but they have to do that as per tender sort of thing. They have to do that, but they forget and they assume that it's not required. And it's common to see shortcuts on the curing times also. They don't cure well. Lining thickness and some of these barriers you can see this lining is not proper, curing is not proper, and joint treatments is not proper. Your supervisors, engineers, assistant engineers, or regular engineers, they are with the contractor so that this doesn't happen to this perfect shape and all that. That leads to rapid iteration that no one saw coming. Okay. So lack of quality testing, as I said. So the quality testing should be done, but sometimes what happens, it feels like everyone is trying to skip the boring quality assurance checks. But though it's very boring work, but you have to do that without quality checking that doesn't fit well to this construction thing. Then alarm sheet, as I said, sometimes land equation issues, encroachment of this straight part into a twist in the road. This ILR or reverse linking projects. So many of the times, rather 90% time you see this, there is a twist in the canal taking up because people dwell there, people set up on the shops. So they start doing some sort of things and you have to talk to the PWD people, this road construction people, they won't agree to you. So that realignment makes a very difficult sort of issue, in particular the ILR sort of thing and giving the papers. Then sometimes technology adaptation, there is a resistance to that. So trying to convince this field staff, particularly contractors, to this embrace the wonders of drones or GIS or telemetry or advanced text, they don't understand. They don't understand that. It's like trying to convince a fish engine swimming in a desert. These some sort of thing occurs with us. The real challenge is there, not just to not the resistance, but the lack of training. Because these field engineers, they are just trained after BTech or MTech. They do not know what is happening in the world, real world. So they resist to take this adaptation sort of thing. So imagine being handing over a drone to a fresher and told him to just fly it. That sounds funny. This same sort of thing happens there. Data and misinterpretation. Sometimes these new engineers or the old inexperienced engineers, they make the mistakes. So GIS maps look wonderful, but when you try to match them with this terrain, you realize that they have been creatively interpreted. So that is what the mistake comes. So what we have here is a classic garbage in a garbage out sort of thing. And that's how we end up in planning errors, and that would have been avoided if we just checked in field. And sensor calibration sometimes. Sensors often do not survive the harsh field conditions during high floods and all that. It's like owning a car that you drive in the rain without ever checking the tires. Expecting good data from the uncalibrated equipment is like expecting a movie to win an Oscar. Okay, that's what happens with us. And our DWDT, that means Godavari Water Dispute Tribunal and the Krishna Water Dispute Tribunal are one of these issues over there, because in the two states, Telangana and Andhra Pradesh, we face all the problems. Rather, every 10 days we face the problem of this, particularly the sensor issues for telemetry and others. The techno-legal issues. You know that Telangana and Andhra Pradesh have been fined 921 crores by Supreme Court and NGT because they don't obey these orders, this thing. Water dispute tribunals. So Palmuru Rangareddy lived scheme and Dindi's scheme and all that. This is just a jurisdiction case, but they have been fined in this case. But still, they have deposited 35 crores with us, but still that is there. Then the next thing, the issues with, I'll just show this tunnel, how it collapsed here. We have this collapse of SLH tunnel. We are rectifying it. Left side electrification part. After collapse the tunnel, we're just rectifying this one. This is while rectifying the tunnel inside. We're putting this compressor, big compressor, and to the starts and all that, and we're taking these lines, and train lines are there for mock, taking the mock out. And how we're doing that, this is really difficult job because some crores will be wasted on this and taking this rectifying and fixing the tunnel. So that is what it happens in the field. As I was telling, the issues with contract, what happens? The first thing that overestimated capabilities. Contractors are very good at overestimate sort of thing. You know that contract who claims to have experience but can barely knows geotechnical word. Yes, they cannot work the work despite all the talk. So now there is a stock and fixing the bags. Next thing is deliberate underbidding. Underbidding they do sometimes because to get this contract and all that, that leads to cost cutting measures but poor quality work. Because with less cost, they will take it, but they will do the work very with less quality. And the surplus time extensions, all the 3 months, 4 months, they will or 1 year, they will try to extend this time for 1 year or 6 months, something like that. It's like buying a car with a price tag that screams sell but has no brakes. Same sort of thing. Then communication gaps. When contractors, consultants, and other engineers talk different languages, you get disputes. Delays also are common, and claims also there. Because once you delay, naturally they will claim for that. And all of that, it starts with someone not reading well this blueprint. They're drawing, they did not study well, but that happens over there. Then sometimes capacity building and training gaps. Field engineers not trained in latest tools. Some engineers still believe that a drone is not, it's just an expensive tool. And sadly, many field engineers are not exposed to the latest tools like drone surveys, real-time telemetry, or 3D modeling. It is as you have asked them to build a skyscraper using nothing but a hammer and nails. Sometimes they do have insufficient practical sessions. We have been to those training programs where the theory is so solid, it could be used as a weapon. But when it comes to hands-on experience, it's like asking a chef to cook without even touching a kitchen. That happens there. Without the real world exposure, training can feel like reading a manual on how to swim without ever getting under the water. These are the problems. So besides this, you have these challenges in dealing with the bureaucrats and the politicians. Frequent policy shift. So this is unpredictable in politics. Today's policy could be tomorrow's something else. That is a mistake. But project priorities change with each new government or top bureaucrats, making long-term planning feel more like an elaborate game of musical chairs sort of thing. Politically motivated interventions. These are there. As I said, DBG, DG link. These are best laid technical plans sometimes take a backseat to political interest. As I was telling that the barrage to be constructed near the village of the politician, that we have to do because that is linked to the chief minister, the other ministers of the president and all that. That happens sometimes. It's sometimes politicians may ask you for canals or realignment or dams to be planned at different locations, as I said, to benefit their constituencies. So that you have to obey, giving your justification for the technical sort of thing. Then delayed approvals and file movements. And unrealistic deadlines and inaugurations, that is there. And every approval takes a detour through this multiple departments where the file gets a leisurely vacation. File slips there. People sit on that. It's like trying to send a message through a broken telegraph message. That's what things which just happen. And then a lack of appreciation for technical complexity. Politicians and bureaucrats, they don't understand the simplistic, they are of the simplistic view that this is a complex engineering problem, but it can be solved easily, maybe 15 days, 20 days, or 1 year. So they don't see dam as a dam. And they see that thousands of hours, our calculations or designs and stress testing that goes in when before them. This is a mismatch, particularly in the expression of this engineers and expression of this bureaucrats and politicians that you have to face in the field also. So what happens next? Sometimes when you are when others are resting, this is a small picture. When what happens when rest of the world are enjoying delightful weekend after their 5 days hustle, field engineers are there in the field in the night time, daytime, during concreting, during the boring sort of thing. We need to there. Even the engineers are to there. They have to make a camp of there. Engineers frequently face complex problems due to ethical dilemmas. Sometimes you see the kickbacks. Upon you think that many doors are open to field engineers, but sometimes the door hits you from back. That happens sometimes to field engineers. And sometimes the ethical dilemmas, right, and office politics. Office politics in the sense that some people will be. This is what happens in office also. If you want to rise up and all those things, there is also a problem in the office politics. There is a problem also ethical dilemma. Some people want to take money, corruption sort of thing. Others they do not want. Some people are motivated that way. Sometimes people, engineers play with this public safety, which should not be done. And there are environmental concerns also, client demands also, financial pressures also. These sort of things you have to bear while in field. Sometimes engineers want that they should be posted in. That means you are engineers want sometimes metro cities posting with all parks and facilities, which are not always available. Sometimes you have to go to the site which is very remotely located, and you have to stay there for maybe 15 days, sometimes 1 month, sometimes living your family, sometimes with harsh climates on that. So these sort of things you should not forget forget from your mind. And besides this, also we have lot many good things in particular engineering, and we have a rich multidisciplinary exposure. This combines civil engineering, hydrology, geology, GIS, telemetry, data analytics, everything, and builds a well-rounded personality within you with practical system-wide understanding. So that is what you get. This is where theory meets the practice in the way this most dividing way. And they also you can have a high demand in government and the multilateral agencies. You can be recruited for large-scale project executions like NSPs and PM CASA projects, JICA projects, World Bank aided projects. Sometimes this needed technical sanctioning and approval, monitoring, and quality control from you are expected from these contractors or big recruiters. And engineers know how to deal with this soil storm politics, as you know, and particularly the politics, which is sometimes the hardest part of that. And those with real hands-on experience are relied upon to navigate huge complex projects and manage donor expectations. After all, when it comes to massive infrastructure projects, your boots on the ground are more reliable than just presentations or making these theories, doc files like making DPS and all that thing. Then you can have this path through senior leadership. Proven field engineers, you can have many things. Like suppose you are coming to UPSC, definitely you will be rising definitely minimum to the level, additional secretary level, that is higher administrative grade level. And sometimes if your job are quicker, you join the job, then you can rise up to the secretary level. Practical experience is a strong base for administrative excellence also. Once you know these things outside in the field, what's happening, you can give quick decisions, you know what is what. No one can cheat you easily. And policy decisions are made by someone who is actually trudged through the muck, walked those canals, like spent days with dusty sites in the dam offices, dam site offices, or canal construction officer, canal lining officer. These sort of things, your these decisions can be taken quicker, and your decisions will have weights. And this is no surprise that field engineers often climb to the ladder all the way to the senior government roles. After all, they have faced challenges at the grassroots and know the real world. Sometimes you get global opportunities like countries in Asia, Africa, and the Middle East. You get this chances. And research consultants, entrepreneurs also you can go for that. And opportunities in the new areas like for forecasting, hard musical modeling, real-time telemetry, and also sometimes you can get in other fields. And you can start your own farm in software design, consultancy, instrumentation, and monitoring sort of thing. That's a boost up point for you. And field knowledge becomes valuable intellectual property, where you know that how to turn it into service offering. Whether you dive into flood forecasting or set up your own consulting firm, and the opportunities are vast. But thing is that you have to remember there is no consultant without the field experiences. If you start this consultancy without field experience, this is null and void. That means you cannot rise it down. Then sometimes you have recognition, respect also. Top environment builds patience because only you have built in the sites, resilience also, and quick decision making. And also you can also earn respects as a dependable problem solver. And while getting going tops, particularly in the site offices, the engineers get going. The ability to make decisions under pressure in challenging environments is what they respect. Particularly in this field engineering, you have this sort of positivity, and these are positive sides of your field engineering. Which concrete is good? Sometimes, suppose practical exposure I was talking about before my talk, how to see these practical things. So you are seeing two pictures here, which is good, which is bad. You cannot just guess like this. So this, if your concrete looks like a well-made dosa, smooth, uniform, no holes, not too dry, you are doing the right thing. But if it looks like patchy paratha, then it's time to back the contractor. So this comes from experience. Because seeing this directly, you cannot judge that it is a good concreting or bad concreting. That a turbine is a bullshit lamp, turbine and bullshit lamp. Seeing that, you can tell the what type of turbine. Left side you are seeing is a Francis turbine. Right side looks like Francis, not Francis turbine. They're different turbine. What is this turbine? This is a Kaplan turbine. This is impulse turbine. Which this movie you just saw now. See, Joe. Different turbine. So seeing this shaft, specific speed you are not going to measure. Seeing the speed it rotates, you can tell that what type of turbine it is. Suppose you are going to see that. So that is what you gain experience in the field. But theoretically, you cannot guess this. When I get bored, generally what I do, so I just go on writing the books. Someone is telling that why to write the books? I told them to get rid of this boring boredom. I write books. I have written 9 books. Out of that, when I get extremely bored, I write this and this scribble this books like this fictions. Those are not fictions actually. These are actually real stories. So when I get bored of writing this engineer books or bored of this real field works. So the practical GIS and water sources are out in 2012. That is only field. What the books which I write generally it is for water sources. Only this covers only the practical aspect, no theory aspect I don't write. Then advanced hydrological modeling. This is for AI, ML tools and data science, water engineering. Recently, some 3-4 months back, wrote it. MATLAB for engineers, I wrote it in 2012. And MATLAB for smart analysts for engineering that I wrote some few days back, though I've written it some 12 years back. This is regarding automation, how to automate gates, how to solve this optimization problems, so how to allocation problems in water engineering really, in crystalline and Goddard basins. So taking those data, so I have written this thing. The resilient basins is basin planning part of thing, how to go for practical things. This is covering this what I can say, this GIS and remote sensing part, practical how to do that thing. Any problem comes to you, how to solve the problems. There are 31 case studies over here. Then statistical analysis in water sources that helpful for this analysis of water sources. In this particular water source case studies I have taken there, around 35, 36. So all these books, when I get bored, I write these books. And during my boring time also in NWA Pune, I guided some 30 masters and some 6 PhDs. Now, though Abnapi said it goes up to 10, but still I guided those things when I get bored. And also important 60 trainings to state and UPS engineers. And also there when I start find times, I go for taking the new subjects, latest subject, all those things. And with all those things, I can tell how you can save a future water governance. To save the future of the water governance, you need to be better. So how to being a better you? So I'll just put 2 stories and just search for lighter sort of thing. One story is that one centipede was on a morning walk. So from a distance, one frog saw that the centipede is on morning walk. He was surprised. How come with 100 legs? How is walking? I have only 2 legs. I am confused. How is with walking with 100 legs? So he went to this centipede, politely asked him, Uncle, so how to manage with this 100 legs? I am confused these 2 legs. I am a poor frog. I do not know. I don't have mathematics. So I do not know how to which leg fast. First leg fast or second leg fast or third leg fast. So which leg sequence? If you forget, what will happen? So how to manage with 100 legs? So the scientific thought, okay, he's telling the right thing. So he praised this frog that you are a big philosopher, you are a big mathematician. So how I didn't think about this. I'm just walking. I didn't think about this. How do I manage this? So he started counting these legs. Sir, do I have actually 100 legs? If I have 100 legs, how do walk? How do I walk? So how to manage to walk? So he started that. So you know that what happened to him? So when he started taking this walk with this counting the legs and all that, he fell down. So once he fell down, was furious. So this he angrily asked this frog, "Why did you ask me this question? After your questions, I got confused, and now I am falling down. So next, don't ask this question to anybody else." And there are hundreds of centimeters that are working, they don't have any problem. And you are asking me this question, so I'm having problem. The cross of this short story is that people are there to criticize you, people are there to comment you, people are there to tell you many things. Please don't care about them. You go on your own way so that you can manage well. And if you go on thinking that why did he ask, and if this intervention of that person I take into account, so definitely you are going to have a failure. So that's the cross of the story that says. Next thing that in real life in engineering or anywhere else in office setup or in even academics or anywhere you see what happens, this is like another story. I am showing a story like a firefly and a snake. What happened? The firefly was just uh, flying. Seeing that firefly giving the lights, the snake was after it to damage it, to destroy it. The firefly was high up. He asked, "Why you are after me?" So can I ask three questions to you? Snake said, "Yes, you asked me three questions." The first question he asked that, "So am I your food stop?" Snake said, "No, you are not my food stop." Then am I on your way? No, you are not on my way. Then why you are coming to destroy me or damage me? The snake said that because I cannot see, I can stand to see that you are giving signing or you are signing. So that is happening in the real world. When you are coming to the field engineering or you are coming academics or you are coming for any office job or coming for any sort of practical jobs anywhere in private, government, anywhere else, you'll have these snakes. Those will be jealous of your signing. They will try to put you down. So please don't bother to them. Don't get bothered by them. So be on your way, and that is what you can be a better being. Next thing that to be a better being, you have to say for realities. You have your choices. You have to choose, take the chances, and you have to change yourself. So that is you have to do yourself. The best important thing is that in any of the things, self motivation is the key. Right? This is the right side you are seeing, and you have to set your own momentum. So unless you are taking your own momentum up to own, so you cannot rise up. So self motivation is the key for prospering anything in the field engineering or anywhere else. So this is what I learned from my 35 years of experience in the field. Okay. And after all, knowledge is not power. It is only the potential. Applying that knowledge is power. So you have to apply whatever, suppose you're writing papers, unless the papers are implemented in the real field, what is the use of the papers or articles? So amid concrete, mod, politics, pressure, and all the things, because they build these lifelines of future. From muddy boards to national blueprints, the engineers shape not the structures, but futures. So your legacy is written by yourself. So make the right decisions in future. And engineers are the individual backbone of national development. I expect that you can take it off with a true spirit, and you can build your own legacy and take the right decisions. So thank you very much for this talk. And now I'll be requesting you to ask me questions if you want to have anything on that.
Thank you. Thank you, sir, for the insightful talk, and thanks for the detailed explanation of the challenges, that we usually face it during the field investigations and during the constructions. Sir, we have gathered some questions from the participants, which we will be asking you first, and
Please.
later we will open the platform for discussion with the participants.
Okay, please.
Okay. So, Dharanya, over to you.
Yeah. Yeah, yes, sir. Thank you. Thank you, sir. Thank
Okay, welcome.
you for expertise and like from the field level for highlighting the challenges that you have faced. So we have the questions that we have received earlier. So the first was what assessment of the water resources management in India? What would you suggest to enhance it?
I could get questions. I could get questions, so please.
What
Question,
is the question? I also couldn't get it.
Yeah, so I'll repeat the question. What is your assessment of the state, current state of resources management in India, and what would you suggest to enhance it?
Okay. So this thing, my answer would be like always try to.
What would you suggest? Yeah.
Okay, always try to encourage one water concept. That means consider all the waters like surface sources, ground sources, treated water sources as one source. That is first thing. And as if they are interconnected and manage them holistically at the state and local levels. That first point will be going like that. Second, my point will be water efficient irrigation techniques like drip irrigation, sprinkler irrigation, through schemes like PMKSY. States like Maharashtra has taken it. So other states should take it up. That is the second my suggestion. Third thing is that water conservation must be taken up by traditional methods and rainwater harvesting of measures, but that must be also taken up. And the last one, I would like to say that strictly enforce the regulations to prevent this industrial and domestic wastewater discharge into the water bodies like Yamuna, and they were being that by NMCG without adequate treatment. They are dumping it, so that strict enforcement regulations is taken. And after also, one fine suggestion I can give it that there should be river basin organizations to look after this water management in India. So that is what we are lacking because river basin organizations are opposed by the state governments and some local bodies. So that is what we are lacking because once that is there, so they will have authority, they will have power to have this. So the state of water management in India particularly go well if you take up these 4-5 points into practice.
Thank you, sir. Sir, if we see majority of our rivers in India are under anthropogenic stress. So what
Yes.
is the future of our rivers, and what are the expectations from the government organizations, from government, from the academic and the research organizations?
It's a very vital question you asked me because all the times I just address on this. The first, the future of our rivers are very in dark. I can say that is there will be water stress and depletion. Now it's 1.140 crores of people are there. So there will be definitely water stress and depletion. There are only 6 river basins out of 20 river basins. Those are surplus. Otherwise, 14 river basins are there. These are deficit. And there will be all pollution and ecosystem degradation. That will be. Then climate change is taking its impact also. And dam construction and flow disruptions are there also. Because of that, we have the RR issues, other difference issues, other things. And also we have the revival and conservation efforts. So that is also taking part of that. And we need to have this integrated river basin management, which is lacking because we don't have RVOs and state governments or local bodies, they are not pulling on well with the center. Because of that, because the state is a, now what is the state subject? Because of that, these are our future of our rivers. And the second part was that how to this academics, particularly this IITs, NITs, or other institute, they should work. Nowadays, what I'm seeing that all these IITs, NITs, or other institutes, they are after papers only. These are 95% papers are useless because whatever research they are doing just for the sake of academics, they are doing that, but that is not implemented in the field. So that must be taken care of. When you write a paper, you must write which can be implemented in the field, like research in the sensor networks or research in the structural health monitoring or digital twins, like industries maintain and manage their assets like bridges, dams, or buildings efficiently. That will reduce these failures and life cycle costs also. That one part this would. That means particularly smart infrastructure and monitoring system, IITs, NITs, or academics, top academics should look at that. Next thing is customized solutions through the industry collaborations. Unless you go to industry, unless you work with industry people, how could you know that what they're doing and what you are doing? There's a lots of gap between industry and academics. So IITs particularly and NITs particularly should offer tailored R&D solutions through these sponsored projects and technology transfers, addressing the specific challenges such as say soil stabilization, earthquake resistance, or urban. Just one second. थोड़ा देर में बात करता हूँ. Okay. Then earthquake resistance sort of thing, then urban drainage designs and not theoretical solutions. And so that's what they should go for. And the third part, I should just suggest and request that the strategic water diplomacy research, particularly we are having the transboundary issues with China, with Pakistan, with Nepal, with Bangladesh, with Bhutan, these sort of things to solve it. this hydrodiplomacy particularly, the hydropolitical risk assessment they should go research for. And the simulation models through the academia and the think tanks, they should concentrate on that. And they should collaborate with this global institution particularly to build this knowledge and advocacy tools particularly for transboundary water security. So these things are missing. Besides that, there are many things to be taken up. So these are my strong points where academics work, and that should be more practical than theoretical.
Yes. Sir, one follow-up question I have to this, because we see interlinking of the rivers is one of the one of the way to address the water stress in the country. But we
Yes.
see there are certain challenges that are associated with the interlinking of the rivers. Do you think how this environmental factors or the ecological factors that play a role in deciding the feasibility of the interlinking of the rivers?
That's a nice question again, because I have been working. I had worked for 5 years as chief engineer in the interlinking roads. I was heading this Western India and the Peninsular India particularly, linking the severe 16 interlinking projects. Here we have lot many concerns, lot many issues, lot many challenges. I say, for example, I'm telling you, there are environmental concerns. So they think that there will be potential for loss of biodiversity. This is definitely because the fish species in Krishna cannot be same as that of Godavari. Well, joining this Krishna, Godavari to Krishna, there will be this loss of biodiversity. Then there will be submergence. Definitely, without submergence, no project can be done. Then ecological imbalance in donor and receiving basin, that will be there. But still, we need to go for that, looking at these prospects and benefits of that. Then there will be displacement and social impacts, because there will be unrest by people. There will be displacement of people to the other areas. There will be interstate water disputes, because there are 8 interstate water disputes I'm talking about. If you give a time to me. In this interstate water dispute, this is very strong, because they go to Supreme Courts. Supreme Court has set up this dispute tribunals. They are going for that. If you take up interlinking project also, we are not successful in some of the areas where this is only one issue. There are many issues like land acquisition issue. There is this pilferage issue. There is fighting between the farmers and this industries issue. There are fighting between the domestic and there are many issues which I'm not able to discuss in some time. There are many issues over there, but these are the main issues which are just true. There are challenges are there and issues are there also. We have to solve that, seeing the benefit of the country, seeing the benefit of the region, seeing the benefit of the state.
Yes. Sir, one more question I have, because we see, I mean, we often hear, water conflicts between the states like Kerala and Tamil Nadu, or Karnataka
Yes.
and Andhra Pradesh.
Yes.
My question is, how do we see the future of water sharing between the states, and how is its impact going to be there on the water management?
Right. See, we have Krishna capability. We had come in 1976 capability to give us award one. Capability 2 is going on. It has result has not come as it. There is Kabel dispute. There's Godavari dispute, Manu dispute, Yamuna dispute. That is you have Ravi Vyas dispute, Bansara dispute between AP and Odisha, Mandavi dispute. That's Mahadayi. Mandavi dispute, Goa, Karnataka, Maharashtra. So all these things are after only this water. Okay. So here, so this future scenario will be we have to have this legal and insurance changes. So what is the concern of this, that we have to have legal and insurance change challenges which need to be solved by these courts as quickly as possible. Then this inefficient water use and over dependence on the water, we have to think of that. We have to devise some engineering measures so that we can have this efficient water use and dependencies are lost there. And obstruction of basin wide planning. So that is there. We have to lose it, destroy it. And we have to have the basin planning, and from starting from macro to micro and micro to macro. That we have to see. Then also political tensions and conflicts are there also, because parties they differ with their opinions and their views. So that we have to take into one board. And there are certain opportunities for collaboration. We have to look at the opportunities which you can look at this. And then definitely this 8 tribunals which I just told now, that can be minimized to a certain extent. And we cannot wait for 20 years, 30 years to for the tribunal to come and give its award, and then will obey by that. So there are many disputes and many details of that. So this is my opinion regarding this.
Yeah. Sir, I mean, again, under present circumstances, we are seeing the transboundary water issues, and
Yes.
that may arise also in future. How,
Fantastic.
as a country, we need to prepare for that, because we are now
Fantastic.
seeing this Indus water treaty issue, and
Yes,
China
yes.
building the dam on the Brahmaputra river. So
I just
how,
about
as a country, we need to prepare for that?
yes. So what you can do in the beneficial way, that strengthen the bilateral and multilateral dialogues if they're agreed to. We can engage China through the regular diplomatic channels and advocate for formal water sharing agreements. And we can push for regional cooperation platforms like with Bangladesh, Nepal, and Bhutan to present a united voice. That can be done. Next thing you can think that do that, establish a real-time data sharing mechanism If China is not giving us data, we can have otherwise we can develop our own independent satellite and remote sensing systems to monitor the upstream side developments. That we can, and also we can have this early warning system. Sometimes suppose China gives plot to us, instantly releases plot to us. We should be prepared for this EWS sort of thing so that the downstream side is safe. And we can build this strategic water infrastructure, like we can develop this buffer reservoirs. We can have these flood control infrastructures, or we can have this run of the river hydropower projects as in the agreement is there in Arunachal Pradesh or in northeastern states to assert rights and regulate flows. Also, we can expedite development of multi-purpose projects in the border regions, particularly. And we can go for the legal and institutional frameworks, like we can push the regional river basin treaties under these international law principles, like no harm and no equitable use to regulate these transplantary actions. Also, we can strengthen the domestic legislation about coordinated river basin governance, which now India is taking it up in Jalam River and all that. And also, we can have the international pressure forums. So, using these international forums to raise the concerns and press for transparency and cooperation, so that other countries will be taking care of that. Like align with global powers like regional allies like Japan, Asian nations, of that, and so that they can counterbalance the China's unilateral moves. Sometimes what happens, China is some other type of country. It may not listen to us. It may not cooperate in this transplated water issues. In that case, engineers can take very grave steps in that engineer solutions particularly. So in my view, they should develop this buffer storage reserves, as I said. So build strategically located dams and reservoirs in Arunachal Pradesh and Upper Assam to store excess water during floods and sudden release from the upstream Chinese dams. Let them release, doesn't matter to them, but we can reduce our disaster risk and ensuring supply during the lean periods. Second thing you can do that, we can construct these embankments, floodways, river turning structures along the Brahmaputra and its tributaries to minimize the flood damage from sudden surges caused by these Chinese dams and natural glacier outbursts. So this globe sort of thing we can change by flood control infrastructures. Third one, we can do that, accelerate this run of the river hydrology, as I said.
Yes.
We can develop our multiple small to medium run of the hydro projects in the northeast part of India and utilize available water before it exits Indian territory and reduce the dependence on unpredictable upstream flows. And we can strengthen the river monitoring and early warning system, as I said earlier. And at the same time, also we can enhance this inter-basin transfer capabilities. And though we are doing that, only one link is active. Other links also can make active, like Mechi, Bihar. Also, I forgot its name. PKC is coming off. Kosi Mechi is coming off in Bihar. And we can plan and implement interlink rivers in diversify the canals to reach water from the surplus zone to deficit areas. So then we can also promote groundwater recharge and local storages. So we can create a decentralized water storage through the check dams, recharge wells, and artificial aquifers, vulnerable regions, so that we can solve these problems to the greater extent. Okay. So these are my views on this.
Yes, sir. Coming specific to this Indus Water Treaty, I mean, what according to you, short-term measures that we could actually follow is, for improving the storage of the hydraulic structures that we have.
See, first to understand the Indus Water Treaty, there are 6 rivers. Okay, so
Yes.
this Indus Water Treaty was in 1960. Okay, so Pakistan uses it this treaty as a diplomatic tool to delay the Indian development projects. Okay, that is one their concern. They're not concerned. That is the trick. Okay, they use it as a diplomatic tool. Treaty has survived. Treaty has survived many wars and hostilities. This is that's showing our resilience, but not equitable in the current context. So there are 6 rivers. Say eastern rivers we have Ravi, Vyas, and Satluj, and western rivers we have Indus, Jhelum, and Chenab. The eastern rivers Ravi, Vyas, and Satluj, that is only for India. They can use 100% of the waters, and western rivers particularly we can use only 20% and 80% to be used by Pakistan. And it has been decided by PIC. PIC means Permanent Indus Commission. That Permanent Indus Commission means India and Pakistan jointly together, they have this commission, that is PIC. So there they have decided that 80% water will be used by Pakistan. And now what happens because of this war or what happened in Pahalgam sort of thing. So this many of the projects in this rivers has been objected by Pakistan, like Baghdad project that has been objected by Pakistan for design issues. Though we had design issues proper, but still they objected that. So finally that was solved in 2007 by neutral experts. Then we have Kishan Ganga project. So now Pakistan objected that. Court allowed the project but asked India to maintain the flows. And the Ratal project there also. This is delayed because there is diplomatic protest in Pakistan, and construction resumed by government of India recently in 2021. Then Pakaldwal Dam and Lower Kalnai, these two dams also objection raised by Pakistan. So these causes these repeated Indus Commission discussions and delays. Because of that, we also suffer, and they also suffer. And this Barsa project also, this is a tourist project. Indus in the mainstream of Indus, but still there is a technical environmental clearance stages. So there are so many projects on Chenab, Jalam, and this Western West particularly, and there are around say I can say around 5,000 megawatts of power can be generated from that, maybe 5 to 6,000. So because of that, we are lacking because we could not generate power. Only two are commissioned. One Bagliar and Kisanga both are commissioned. And Ratley is under construction. Sawalkot is under planning stage. Pokaldul is under construction. Borsar is proposed. It not has been started as yet. And Pokaldul is this as I said under construction. Nothing. And we can maximize the utilization of eastern rivers. What we can do, though we have 100%, but still unutilized water goes to Pakistan. We aggressively can invoke this Article 7 also. So Article 7 of PI is there for future cooperation. If they don't agree to that, Rabi, Vyas and Satluj water through dams, canals or intervention transfers, we can reduce the unused flow to Pakistan so that we'll be benefited and Pakistan will be at loss. So that sort of thing, the strategic measures we can take. Or else we can take this, or else means end we can take this run of the river projects. We can expedite the construction of this permissible hydropower projects like Baglier on Western rivers. So that can also good thing. Next, we can use this IWTR strategic leverage, non-military pressure tools. Suppose you can by halting the joint commission meetings, or for the cross-border hostilities, we can stop the water. Like our honorable prime minister did the best thing that he did. So this some sort of thing we should do that also, because if somebody is not listening to us, so better to teach me in the other way that. We should have the bilateral diplomatic dialogue if it is possible. If you resolve the disputes faster by bilateral diplomats, nothing like that. But sometimes that becomes a problem. Sometimes we can go for peaceful sort of thing by international alliance also. So there, the friendly rival nations are there. We have to those who can create some soft pressure on Pakistan to comply with the treaty norms. That also can be done. So these are my observations with this inter-soda treaty. But once you want to go details of that, then this requires a special time to discuss it. Okay.
Thank you, sir. Vijay, over to you.
Yes, sir. Yes, sir. Thank you, sir. So
Yes.
I have a question.
Yeah, please.
My question is: are we able to utilize the hydropower potential of the country, and how environmental factors?
Okay.
Yeah.
See, hydropower potential is enough in our country. Enough means enough. So we have estimated that's around 145,000 megawatt we can generate, right? But only until now we have only generated 40% of this effectively. Okay. Current status is that 47,000 megawatt as on 2024 we have generated, but it's around 47,200. I can say up to 25. But potentially yet to trapped, that is around 90,000 plus megawatt, particularly in Himalayan states, Arunachal Pradesh, Uttarakhand, Himachal Pradesh, and J&K. The challenges which you face in this potential development is that environmental and social concerns. There will be displacement, there will be deforestation, there will be biodiversity loss, as I said earlier. And also there will be delays due to land acquisition, because land acquisition is a very major problem in state governments, particularly because land is owned by the state governments, and clearance by MOF and WOTA, that's because difficult thing. Then also we have the interstate and inter-agency conflicts that we need to also look into. And geopolitical issues are there also in border regions, particularly in Assam, Manipur. You know that Manipur having some problems over there. And that is there also. So to look after those things, you have to survive those things. Then only you can go for that. Then also financial unviability. Sometimes the benefit cost ratio you have to neglect sometimes. Sometimes I can tell whenever the tribal areas are there, these financial unviability you can't neglect, and use high capital cost and low investor interest. You have to see that. And what we can do the best, that we should request government for the faster clearance with the green norms, and we can have this small and hydro micro projects sometimes we can develop. And as I just showed in the movie, sometimes clips, that is Pinapuram, IRP Pinapuram, integrated renewable energy project Pinapuram. We can have these hybrid energy models. So where much of water is not required, we can trap this wind energy, we can trap this other energy, solar energy. And we can revive stall projects and religiously rehabilitate these stall projects. So then with PPP board, with this public-private partnership board, if you can do that, that's one of the things. then you can have modernized the existing infrastructure that you can do if your money or your financial things are not there. And you can enhance this interstate cooperation and grid integration for power sort of thing. So once you promote this regional power pooling and incentivize the surplus states like Andhra Pradesh and other things for hydropower sharing, that will be better and that will be a robust network of development and enhancement.
Sir, I just would like to share my experience here. I was a part of Tawang River Basin Management Plan, where several
Which one's it? Kamang?
Tawang, Arunachal.
Tawang. Okay, Tawang, Assam. That
There were many hydroelectric power projects that were planned, but unfortunately, none of the hydroelectric power project got approved because of the environmental reasons. There are very specific, what I should say, regional issues that could not actually allow the approval of the hydroelectric power projects in that particular region.
Yes. That is there because Minister of Environment Clearance is a different entity because they are different entity. WOTA also that is required. MOA clearance and WOTA clearance both are required to take up the projects. So if project, any project to take it up, these are having some problems of there. So there are regional disparities, there are regional feelings of environment sort of thing. There are like some ABC persons coming up. Those are environmentalists, so to say. See, the environmentalists, they cause many of the issues over there. Engineering cannot help them out because they do not understand engineering. They do not understand anything. They just what I can say, they can tell these people those are illiterate or not educated enough, so that they are coming with that. Lakhs of people coming with them, so that we suffer. And a country suffers from that.
Thank you, sir.
Yes.
Thank you, sir. Sir, and follow up the question, like how environmental factors play a role in building dams, and what is your opinion on building large dams?
No, that's good thing. You can have large dams, but thing is that you have to see many small dams or a big many small dams or a large dam. You have to see which is better. So if you take up this large dam, in my personal view, the large dams are better. Suppose you are RIS or you are like Koyana Dam, reserve industrial facility, that can be neutralized. But large dams can store water, that evaporation loss will be less. And if you have many small dams like you check dams, these small dams, so that will take more of space, that will take more of land acquisition, that will take more of time. So it's better you have to optimize whether to go for a big dam, one big dam or many small dams. So in my view, big dams are better, but though it has certain limitations, it have more implications on the rehabilitation issues, particularly because rehabilitation R&R cost becomes too high. So that you need to see, and land acquisition also is not much because the height of the dam is more, then the land acquisition will be lesser as compared to this many number of small dams. That we have to optimize and see which is the better. But in my view, particularly, if you store more water, particularly, then this dam is all right because India stands at very low level of this water storage. Because of that, only we are suffering. So 450 BCM of water we have for storage capacity. We need to take it to 1,000. It is 800, 900, so that a drought period can be at least resisted. So this sort of thing, in my opinion, that is there.
But instead of MATLAB, you could have written some book or is free software. I commented on your publication that I still like R.
Yes, I know.
MATLAB. Later on, I found that I may not have access with the MATLAB thing.
No, I started with R. No, I started with R, but R I did not get fascinated, so I started because while doing this, I was generally I have mastered more than 100 software packages in water engineering, more than 100 many. So long back in 2008, I was master of those things, and your Start Pro, Start Fund, all those things I was using that. Then later on, I thought that it's better to take up MATLAB because Simulink is there and virtual reality is there. Because why did I take MATLAB? I wanted to have automation for this Viswasara Dam, the gates in Pune, National Water Academy. Sitting in the office, I can operate the gates, putting the actuator over there. So because of that, I learned MATLAB because Simulink is there. And virtual lead there, I can see the virtual lead sort of thing, and with Simulink, with an actuator, I can operate the gates. Because of that, because R cannot do that for me. Because of that, I took MATLAB and I took interest in that. That is the story behind. Because every book I have written, I have a story behind that.
Okay. Sir, I just have one question. When it comes to watershed management practices, it differs between Himalayan catchments and the peninsular catchments, right? So can you throw some light on that? How do the catchment scale management practices that we do in Himalayan river basins and the peninsular river basins?
Yes, sir, there is very much difference between the two. This catchment scale water management is quite different in both the things, because in Himalayan and Peninsula, we have first in topography and slope dynamics. In topography, we have the Himalayan basins, we have steep slopes, we have fragile terrain lead to higher erosions, landslides are there, sediment is more. Peninsular basins, we have gentler slopes with more stable geology that allows for long-term soil and water conservation structures. And coming to rainfall and flow regions, Himalayan that gives snowmelt and glacier contributions lead to this perennial flows, but also flash floods during monsoon, like Rati in 2008 September. I had experienced that. And peninsular basins, you have this rainfall with the seasonal flows that makes the rainwater harvesting and storage critical. And then you have this, land use and vegetation issues. In the Himalayan basins, we have forested upper catchments while shifting cultivation, zoom chas, what you call zoom chas, zoom cultivation in the north east part are sensitive to deforestation. And peninsular region, you have this particularly agricultural lands and degraded forest lands. So more of scope for agroforestry and water soil restoration. And next point I can talk on that, that's soil erosion and sediment control. Himalayan basins, you have the high sediment transport requires bioengineering and slope stabilization techniques. Whereas this peninsular component, you can have the soil conservation that is focused more towards bonding or control trenches or check dams or some sort of thing like this. Also, beside that, you have this infrastructure and accessibility. Himalayan basins who have difficult terrain limits, so large structures and community-based decentralized systems are more suitable for that. And peninsular basins, we have better access that to enabling watershed development programs with the bonds, tanks, or EVS systems like you have in Tamil Nadu, Andhra Pradesh, or some part of Telangana, though it's less. In Karnataka also will make more, see more. Since this royal ages like king ages, we are having disruption. These are the differences between catchment management and function.
Thank you, sir. Thank you, Vijay.
Yes, sir. Yes, sir. I have another question.
Yeah,
So,
please.
why it is not easy to get hydrological data in India? And I mean, why is why
Right,
is
right, right. I could
data
get your
sharing
point.
policy is not easy? Yeah.
Yes, yes. No, so problem is that's the end. First thing is national security concerns, because data is available with Central Water Commission, with IMD, with particular state water departments. Now, if you talk of this national security, first point is my national security concern. Water bodies, especially in border areas, are considered sensitive due to their strategic significance, like dams, barrages near China and Pakistan. They cannot share data generally. That leads to data classification under defense and national security activities. So like, for example, Brahmaputra and Ganga, we have made it classified data. Though you can get the data from the Minister of Jal Shakti, you writing a form and filling a form, giving undertaking, that will take 4 or 5 months to take the data. But all the data will not be given to you. Those are very strategical classified, they won't given to you. And other data can be given to you. In flood season, data will be easily available. And non-monsoon season data will not be that much easily available because of this national security concerns, because people die during non-monsoon seasons for that thing. Okay. Then second thing is that institutional fragmentation. Okay. Because CDO is collecting data, IMD is collecting data, state development is collecting data, CGW is collecting data, and they are having little coordination between them, because CGW is collecting groundwater data, CDO is collecting surface water data. State development is sometimes monopoly, they are collecting both the data and they are not taking that properly data sort of thing. And unified data sharing framework is not there, that is absent. So also certain problems I can tell that data are in silos, and these are also some bureaucratic hurdles are there. Okay, so starting my topic was there from files, blueprints, bureaucratic these things. So engineers becomes a bureaucrat sometimes, though bureaucrats are there, but still engineers have become bureaucrats sometimes. And in segments particular, there are more bureaucrats. And these bureaucratic hurdles also that gives problems to us. Then state versus central control conflicts. So as we are discussing just now, that what is the state subject in India, and many states are reluctant to share the data with central government and other also with other states. They don't generally share because of this interstate river disputes, and most of the states are with its interstate river disputes and political mistrust that is there. Because of that, they don't share that. And next is that the lack of modern data infrastructure and transparency culture. That is, uh, many data sets you will see that they are still collected manually or stored offline. And there is a traditional culture of data secrecy rather than open access. Even if you see your friends, those are doing you are doing PhD, you see your friends, if he is having some data, he will not share it with you. So this same sort of thing happens. This same sort of thing happens here also. Even I am seeing that some professor in IIT is asking for data some few days back, I mean 4 or 5 days back. Same IIT, same department, two professors asked the same data to me, and I have shared with one. The another one did not get it. So I told already I've said with that. So no, he didn't give me, he won't give me, please share it again. Anyway, so that's, I am not telling that, I'm not blaming any professor, I'm blaming anything, but that sort of happens, sort of thing happens. Similarly, like human beings, the states also they behave like human beings. Okay. So that's what my observation is. Okay. So that is what this data sharing becomes difficult. Okay. Neutral. We want to develop public, we want to develop states and all that. Any questions further, please?
Yeah. Dharanya? Uh,
Yeah, yes, sir. A slightly off-topic question from all the technical is that we have discussed so far. So, what are your interests outside your professional workplace? So, if you have any interest in music or watching movies?
Yes, I have interest in the sense that my hobbies, I don't have a specific hobby, but I generally write. 25 years back, I was writing articles in Types of India, but then after that, I stopped it because I had a lot of work in the field. So after that, yes, of course, I listened to this Jagdish Singh ghazals and write it.
So, sir, thank you so much for your time and for discussing the valuable things. I mean, I have noted down the points that you have told us. We will now make the terms of reference for the WhatsApp group as well, so that we could more improve the content in the group as well. Thank you, sir. Thank you so much.
Thank you
I
very
would
much. Thank you.
yes, I would now request Dharanya to formally give the vote of thanks for the today's talk. Dharanya?
Yeah, yes, sir.
Yeah,
Yeah.
please.
Thank you all on behalf of Grow, and I sincerely thank you all for your attention and time today. It was our pleasure and honor to have Sankhua with us. So your expertise, your reflection from the challenges you faced brought us light and gave us a lot to think about. And as a younger generation, will take this learnings forward. So the session was really interactive and engaging. A heartfelt thank to all the participants who stayed throughout. Thank you again.
Thank you, sir. Thank you so much.
Thank you very much. Special thanks to Professor Biswal and Professor Dr. Kunalji. Nice to see you all, and thanks very much to all the participants, those who have come all the way to listen to this.
Thank you, sir. Thank you so much. Thank you.
Thank you
Okay,
very
sir.
much. Thank you very much. Okay.
Okay, sir. Bye, sir. Bye.
Okay. Thank you all. See you again. Okay. Thank you.
Okay. Bye.
Thank you. Thank you.